Welcome to Mastering Solutions. So let's write a list of the variables that they give us in the question. We know lambda is 532 nanometers. And now we're talking about the distance from the Earth to the moon. And so that is where our L is going to come in, because the Earth is where the laser is shining and the moon is essentially our viewing screen here, right? So we have 384,000 times 10 to the 3 meters. So this is our L in standard units. And so now what are we trying to solve for in this question? They want us to figure out the diameter of the opening of the laser. So that is going to be D. The equation that we can use for that is W is equal to 2.44 lambda L over D. And this is the width of the central max on the moon. And this is the width of the opening of the laser. So let's multiply both sides by D, of course, divide over W. D is equal to 2.44 lambda L over W. Okay, so this is the equation that we'll be using. And so D is equal to 2.44, and the lambda we said is 532 times 10 to the negative 9 meters. And then L is 384,000 times 10 to the 3 meters. And then all of that gets divided by W. But we said that we don't want it to be any bigger than 1 kilometer in diameter. So we'll use that to set the width for our diameter. So we have 1 times 10 to the 3 meters. So we have 2.44, and that's multiplied by 532 times 10 to the negative 9 meters times 384,000 times 10 to the 3 meters, all over 1 times 10 to the 3 meters. So the width or the diameter of the opening of the laser, we need to use one that is 0.498 meters, 0.498 meters. And so rounding for significant figures would be 0.5 meters or 50 centimeters. So that is a very large laser, a half of a meter in diameter on the opening to allow us to see it on the moon with the diameter on the moon 1 kilometer.